going on here. I want to go through these quickly before we get to Blumen's tax. Explanation D is one that economists typically dismiss for a long time. It turns out there actually are studies just in the last 3 or 4 years where they put people in rooms at different temperatures and measure productivity. They do that. You also have some studies that are able to measure individual productivity day by day on hotter and cooler days. There's now a study looking at test-taking performance. This is a study using Kenyan data. Test-taking performance as a function of local temperature variability on the day of the test. Does it just happen to be a really hot day on the day you took the test or not? In all those studies, once you get to about 27, 28 degrees Celsius, so like low 80s Fahrenheit, you start seeing a decline in performance. So it's pretty flat to that point. Then you start seeing a decline, and then at some point it just plummets at very high temperature. So there's actually more and more evidence that channel D could matter in a substantive way. But this was an explanation because it's based on biology that I think economists traditionally dismiss. They say, that can't be it. We know everything. We're economists. A, we're going to talk about the history of sort of colonial settlement, and we'll talk about whether that's an accident or not. B has to be important. Whether or not it's like the key factor, we don't know, but it has to be important. It's just a lot easier to access markets that are close by. So I think all of these, there's something to all of them. But next we're going to talk about agricultural productivity with Blumen's tax. Yeah. Yeah. Okay, so you raised the issue of adaptation, which is, let me just write that here. The question of adaptation is the key economic mechanism or economic factor that when people say talk about climate change or talk about high temperatures is the open question. There's very little good data on how much adaptation there is. Now, to some extent, there has to be some adaptation. People living in a certain climate are going to adjust their behaviors and their economic activities to local conditions. But a variant on that question is, let's say climate changes gradually for the next 10 or 20 years. So if we think climate change is going to increase temperatures by a few degrees, how well are people going to be able to deal with those changes over 10 or 20 or 30 years, which we can think of as medium run? Surely over centuries, there's adaptation of institutions and other things. The evidence on that is really limited. So this is like the big question in the economics of climate literature. How much adaptation should we expect? And how can we promote adaptation in societies that are experiencing a change in climate? That's a very active research area and obviously a big question. Because if people can adapt, then maybe climate change isn't that big a deal. If they can't, and it takes them decades to really rework their economy to a different climate, people will suffer a lot during that period. Okay. What's my answer on adaptation? Oh, if I were sitting there? Okay, hold on a second. I'd be pretty tempted to go with E. I know too many papers on each of these to say which one is the most important reason. It'd be pretty hard for me to say. But I'll go with E. I'm going to go with E. But actually, there's something to all these. I put these up because there's actually something to all these. And we're going to go through a lot of these explanations in the course. There's a hand up, yeah? Tourism is a really big sector in a relatively small number of countries. So there are certainly countries where tourism is huge and very important, but say in sub-Saharan Africa, tourism is only a major sector, and I can think of 5 or 6 countries out of say 42. So tourism is going to be important in some particular cases, but it's not going to be I don't think people think it's the key driver. There's not much tourism to Benin. There's not much tourism to Mali. So actually Mali has Timbuktu, but let's say Niger. There's not much tourism to Niger. So yeah. Yeah, that's a great way to test it. So what you're saying is actually a great idea. Let's not just think about tropical geography, the tropics aspect. Let's think about distance to markets. We can test that. It does turn out that in international trade, a very important predictor of trade is distance to the market. So the farther away you are from a market, the less you're going to trade with a certain partner. So yes, what you're thinking of is a very nice sort of test of distinguishing the tropical areas far from markets and the tropical areas close to markets. That's a great idea. Okay, so let's get into Blumen's tax. What are these agricultural factors, and how does it work? Their main claim is it's a general pattern that yields are lower in the tropics. Yields per acre are lower in the tropics everywhere. The question is why. And so I want to step back. We're going to start thinking about causality now. We're going to start thinking about going beyond interpreting correlations or broad patterns to thinking about cause and effect. And this is going to be one of the main themes in the course this term. So in poor tropical countries, agricultural productivity is low. And the question I want to ask you guys, and there's really no answer, we're going to get to it little by little, is agricultural productivity low because these are poor societies that don't have access to capital and don't have access to as much education or access to technology? So is the poverty driving low productivity? Or is the low productivity the cause of the poverty? See that distinction? Is agricultural productivity low in sub-Saharan Africa as a result of Africa's poverty, or is it the cause of Africa's poverty? Or both. I mean, it doesn't have to only be one or the other. Okay, just keep that in the back of your mind when you read Blumen's tax, with everything I'm going to talk about today. Keep a critical causal lens on. Just because we see a pattern linking A and B doesn't mean that A caused B. It might be, it might not be. Okay, so let's just keep thinking in those terms. What are their explanations for why there's lower agricultural productivity? The first thing they point out is rainfall patterns. Rainfall patterns that are driven by global weather and global climate patterns. So the two things that they point out are A, sub-Saharan Africa gets a lot less rainfall on average than other regions. I'm going to show you the data in a second. A lot less rainfall. B, the rainfall that Africa gets is much more variable. Year-to-year variability, no matter which statistic you use to measure variability, year-to-year in a certain part of Africa, there's a lot more variation in how much rainfall you're going to get than year-to-year variation in the location in most parts of Asia. And that's driven by global weather patterns. There's a very large monsoon phenomenon that hits most of Asia that, yes, there's variation in the monsoon year to year, but it is a large, like a massive regular weather phenomenon that brings tons of precipitation to Asia. Very few parts of sub-Saharan Africa have a regular weather phenomenon of that kind. And that just leads to a lot more variability. So what does the data look like? The red line here is sub-Saharan Africa, the green line is Latin America, and the blue line is Asia. Now, can people see it or should I turn off the lights? Can you kind of see it? You can see it okay? Nice. Nice. Good. Okay, what do you see here? How would you characterize these patterns? Which region has the highest mean rainfall of these three? Looks like Asia, right? I mean, the mode is shifted, the peak is shifted to the right tail is much thicker. You have many parts of Asia, like lots of mass in the distribution, just getting lots of rainfall per year, 2,000 millimeters per year. Latin America is sort of somewhere in the middle, where you have some drier and wetter parts of Latin America, but sub-Saharan Africa is all the way over on the left. And this is data for this, 78 to 2000, which is sort of the period Blumen's tax are writing on. So I focus on this period, but you see similar things subsequently. So what does this mean for us? If we think that it's just very hard to grow stuff if you're way down here, a lot of Africa is way down here. A lot of Africa faces years with only a couple hundred millimeters of rainfall in a year. So if you have, say, 30 millimeters, that's 300 millimeters, that's 30 centimeters, that's like 10 inches of rainfall a year. It's not very much rainfall. Okay, so if we draw a line at around, say, 500 millimeters per year, there's very few parts of Latin America and Asia that have that little rainfall, but there's like tons of Africa that has that much rainfall. I just sort of colored in that part of the distribution. So in any given year, a lot of African countries are basically in drought or near drought conditions. That has fundamental consequences for agricultural productivity. If you don't have any water, how are you going to grow anything? What's particularly difficult is year to year, particular regions are bouncing around on this red distribution. Good years, bad years, good years, bad years. I'm going to show you that in a second. Okay, any comments or sort of reactions to this distribution? What else do you see? Yeah, Michelle. The y-axis here is just the density. So I should have explained that, sorry. These are non-parametric densities. Basically what these are doing is telling us what the distribution of rainfall looks like in a very smooth way. So what this is saying is the higher we are on the y-axis, the more country year observations we have at that point, basically. So there's a lot of country year observations on the blue line in Asia at around 2,000 millimeters of rainfall per year. There's a lot in Latin America at around 1,500 a year. That's where a lot of the distribution is. But in Africa, it's shifted to the left, towards less rainfall. So sorry I didn't explain that. Any other questions, thoughts, reactions to these distributions? Yeah. Yeah, that is a great question. And this, I think, gets back to the sort of interpretation issue with Luhmann Sachs. So you're raising this really important issue of, irrigation. The need for irrigation seems much more severe in sub-Saharan Africa. The ability to store and distribute water is more important when you have less water, you would think. It also turns out, though, that there's far less irrigation in Africa than in Asia. So if you look at the proportion of African farmers with access to irrigation, it's less than 10%. So Africans rely on rain-fed agriculture because there's very little irrigation. They can't store water. And they get very little rainfall and highly variable rainfall. That's a bad combination. Now, this is where the interpretation issue comes in. Presumably, if African countries were a lot richer, they'd be able to invest in large-scale irrigation systems. So the loss of agricultural productivity or low agricultural productivity isn't just a cause of African poverty. It's probably also a consequence to some extent because if they were better off, they'd be able to build more irrigation. So it's a great question. Okay, so less rainfall. We talked about that. Arid soil, more variable rainfall. And in fact, if you look over the period in the 80s and 90s that Luhmann Sachs focused on, in this kind of dark period of very low growth in Africa, the majority of African countries during those 12 or 13 years had at least 2 years of extreme drought. 14 of the countries, so about a third of the countries, had at least 3 years of extreme drought. So 3 years out of 12 or 13. What that means is every few years, on average, you're hit with an extreme drought. And that's an incredibly difficult thing to deal with when you're already very poor. When there's an extreme drought, you're going to rely on food aid from your government. You're going to rely on food aid from other governments. You may have to move. In the district of Tanzania that I worked in, that we're going to talk about a little bit this term, just before I started working there, there was a huge drought. The majority of villages were relying on food aid. Tens of thousands of people got up and left and just walked to another district where there was more food, etc. That's a brutal event for people to have to go through. And the reason why it could have very important economic consequences beyond its immediate humanitarian consequences is it could affect the kinds of investments you make. Why would I necessarily invest in lots of very high yield crops if I think there's going to be a drought that year? You can ask yourself that question. So we'll talk about the broader consequences. Okay. There's one paper, it's not on the reading list, because I really just I wanted to show you guys a few figures, but if you're interested in this issue, you might want to read this paper. This is the Barrios, Bertinelli, and Strobel paper from 2000. They document African rainfall over the last few decades. And they find in their data that years of low rainfall were also years of very bad economic performance in Africa. That's not shocking. Africa is a predominantly agrarian region, meaning the biggest sector in most economies is agriculture. There's very little irrigation, so when the rain fails, crops fail, and the economy fails. And that's basically what these guys document. But I want to show you something else, which is they show that the growth collapse, the economic growth collapse in Africa in the 1980s lines up with a rainfall collapse. So let me show you the plot. This is the time series of average rainfall in sub-Saharan Africa from 1900 to 2000. So these guys got the best data they could get their hands on for a century. What's nice about this is you get some sense of what the long-term averages are in Africa. So the way they presented their data, let me explain the axes better. The x-axis here, of course, is years. The y-axis, 0, means you're at average rainfall over this century. So rainfall in Africa was at the average for the 20th century. 0.1 means you had 10% more rainfall than average. 0.2, 20% more rainfall. And the same for the negatives. Minus 0.1, minus 0.2 is minus 10%, minus 20% below average rainfall. So what do you see here immediately? If we put a couple lines in here, the thin line is 0. So this is about the average. It turns out that that period of pretty good growth in Africa in the 60s and 70s was a period where in most years rainfall was above average. And then in pretty much almost exactly 1980, there's this unbelievable drop in rainfall. I put the two red dots to sort of show you that change. You go from being about 10, 15% above average rainfall for a couple decades, for the most part, all the way down to minus 45%, below the historical average. And it stayed, and then the bad thing is, it's not only one bad year, it stayed low. It stays below the long-term average for another 15 years. And you know what happened after that? It went back to normal. The period of economic recovery in Africa after 2000 is a period of basically close to historical average rainfall. So actually, we were talking about democracy and institutions in China. Rainfall is probably pretty important here. Like, these patterns line up a little too well to be a coincidence with African growth patterns, given how important agriculture is in Africa. Okay, what else do you guys see? What other observations or patterns do you guys see in the data here? Yeah.
Does average rainfall stay static this entire time because as kind of progressing this climate change, actually that there's less rainfall for 2000 than there was?
Yeah. So the way they define average is they're literally just defining it as the average over this century as a flat average. But in terms of what we would expect in terms of rainfall in subsequent years, it might change with climate change. Now, the climate models are very interesting. They almost all predict warming. They almost all predict the world by 2050 is going to warm 2 or 3 degrees Celsius. Almost all of them. There's pretty much a consensus on that. The climate models are much more variable in predicting precipitation changes over time. So some of them predict precipitation will go up, some predict precipitation will fall. And then even within those models, some of them predict precipitation will increase in some regions and decrease in others. So there's much less consensus as to what rainfall patterns will look like in Africa in the next 30 or 40 years compared to temperature, where there's pretty much uniform agreement on temperature increase. Michelle? It does. This is, basically in the early 80s, Africa has a debt crisis. Now, part of the debt crisis was global. Latin America also had a debt crisis at the same time. The US was in recession in 1982, et cetera. So, and African growth had already slowed by then. So Africa was sort of entering a period of recession or economic, let's say, slowdown when this hit. So it was almost like the worst possible timing because there weren't any reserves left. They couldn't borrow. They sort of already defaulted. A lot of African countries had defaulted on debt. So, and And this is the period when sort of a lot of structural adjustment reforms are going through. So there's a lot going on in this period, but it's just a terrible period in terms of agriculture. And this 1983 and 1984, famous. It's really the worst drought in history, as you can see in the data here. But this was the period, if you guys heard about this before you were born, but like Live Aid, We Are the World, like all those sort of like famine relief songs when I was a little kid. Have you heard of this stuff? Oh, you have. Good. I just don't know if people know anymore. Yes. This is basically like We Are the World, like right there. That's what happened because there was such a massive drought. The drought spanned West Africa all the way to East Africa down to Southern Africa. And it was like a cataclysmic event. That drought. You can see it here visually. It's a terrible drought. Okay. This is the rest of the world. So this is all of non-Africa. So it's not too informative because obviously there's variation in different regions. But what you can see is if you take the rest of the world averaged, sure, there's some variation, but say over the last 50 years, the world as a whole didn't have huge downward drops in rainfall of the sort we saw in sub-Saharan Africa in the 1980s and 90s. It kind of struck me looking at this, and I hadn't been sort of aware of this. Of course, this is the period of the Great Depression in the world, basically starting in 1929. And I just don't know enough economic history, but it hadn't dawned on me that maybe this was like a period of very bad climate as well. And what role did that play in the global recession? I don't know. So hey, maybe 20 people have written papers on that. I literally thought of this when I was like walking to class. But if not, go and write this paper on the Great Depression and global climate. Okay, so why might highly variable rainfall reduce incomes? We know that in a given year, bad rainfall, if the rain collapses, obviously your crop collapses, you're poor. But beyond that, why might just the threat of bad rainfall lead to lower incomes? That's an even more pernicious problem or kind of dangerous problem. So let's, just in the last few minutes, I'm pretty sure class ends at 5, right? I just want to make sure that you guys don't leave early or anything. Imagine there are two crops, crop 1 and crop 2, and this is just very stylized. Imagine the crop yield is on the y-axis here. And we're going to see what the yield looks like over time on the x-axis, where it's going to kind of fluctuate, say, with the weather. So it's going to be a little bit like that plot I just showed you with some natural variation. The thing to keep in mind here is crop 2, on average, is a higher yield crop than crop 1, let's just say. Just you get more money or more calories, whatever you value, you get more of it from crop 2 than crop 1. Okay? So this is what the profile of crop 2 looks like. And let's just draw up and down years. It's really not that predictable, but let's just imagine look like this. The high points are the good rainfall years. In good rainfall years, you make a lot with crop 1. In bad rainfall years, you don't do that well. So there's a lot of variability. It's a high yield crop on average, but it's also a crop that's very sensitive to weather. That's crop 1. Now imagine this crop 2, which looks like this, the green crop. Yeah, in the good rainfall years, you do a little bit better. But what's the difference between these crops? Crop 2, the way we've drawn it, and there really are parallels. We'll talk about real world parallels. Crop 2 is a safe crop. In those really bad years, you don't do that bad. Crop 2 is a crop that's more adapted to a drier climate, say. You don't lose your whole yield, you just lose a little bit when it's dry. But in the good years, you don't do that well either. So what would this look like in the real world? So for instance, some varieties of what we call corn, what the rest of the English-speaking world calls maize, are high-yield varieties of corn or maize. And actually, when conditions are good, you can have huge productivity with these high-yield varieties of maize. But they don't do very well with drought. In drought years, you may just lose your whole crop. In contrast that with crop 2, which we're going to call cassava. This is a root crop. It's underground. In good years, it doesn't give you that much nutrition. It gives you some, but it does better in drought years. It actually still grows. The whole crop doesn't die. So if I'm a farmer, and we just saw what African rainfall looks like over time, it's highly variable. Which of these crops should I choose? 1 or 2? Yeah. Very good question. How would storing food change the equation here? Yeah, so if you could store, then maybe you could take all this high production, keep it stored for a couple years, and then when you're hit by a bad crop, eat that stored maize. Okay, so storage is going to matter, or savings more broadly, because you could save the corn and you could sell it and save cash. So the ability to save is going to matter. What else is going to matter? Now it really is 5 o'clock. Think about that, and we'll continue on Tuesday. Oh, well, next time. Thanks.